Right, so the first video I'm going to share with you is to help you cover the vectors part of the Pure Maths course in Year 13. Vectors is a really short topic in Year 13. It's just an extension of GCSE and Year 12 vectors. Most of the stuff you will have already met in mechanics, so it shouldn't be too tricky for you. So I'm just going to start by running through some of the notation that you've met in Year 12, and then we're going to extend it into Year 13. So what that does really is take everything that you've learned in 2 dimensions in Year 12 and extend it into 3 dimensions in Year 13. So let's start off in 2 dimensions. So let's say that there's a coordinate A, and the coordinate A is 2 minus 3. Okay. So some of the notation you will have met before, the position vector of A, we could write that as OA, so that takes us from the origin, from 0, 0, up to A, is 2 minus 3, if we write it as a column vector. And the other way that we could write that is using unit vector notation, and that's 2i minus 3j. Using unit vectors. So I is 1 unit in the x direction, j is 1 unit in the y direction. So 2 across, 3 down. So in Year 13, you just do that in 3 dimensions. So say we have the coordinate b, so we had, 2 minus 5, 7, okay, that coordinate there. Then the position vector of b, taking us from the origin to b, would be 2 minus 5, 7 if we write it as a column vector, or it would be 2i minus 5j plus 7k. So this time we have a k as well, so I is in the x direction, j is in the y direction, k is 1 unit in the z direction. Okay. So the next thing that we're going to think about is the magnitude of a vector. So the magnitude is its size. So again, let's start in 2 dimensions just to recap what you hopefully already know. So let's say I had a coordinate C, okay, and the coordinate C is going to be 4 minus 3. Okay, so that's 4 across and 3 down. And the vector that goes from the origin to C, I would call that OC, that's the position vector of C, would be 4 minus 3 written as a column vector. So if I wanted to find the magnitude of it, say I wanted to find the length of that line, I would use Pythagoras' theorem. So the magnitude of OC, the 2 lines either side, the notation for the magnitude. So I would say it's 4 squared plus minus 3 squared, which is 5. So that line there, that vector, has a magnitude of 5. If we were to extend that into 3 dimensions, you have to excuse my slightly rubbish drawing at this point. So there's my x-axis, my y-axis, and my z-axis this time. This time I'm going to have a coordinate D, and the coordinate D, let's say 4, 2, 3. I'll choose all positive numbers so I can draw it in a positive quadrant. So that would be heading up there. So that would be my coordinate D there. And it would be going 4 in the x direction, 2 in the y direction, 3 in the z direction. So the position vector of the point D would be OD, and that's 4, 2, 3. And then if I wanted to find the magnitude of that line, the length of that line, the length of that vector, that would be the magnitude of OD. So we can just extend Pythagoras' theorem into 3 dimensions. So it would be 4 squared plus 2 squared plus 3 squared. So you probably met that extension of Pythagoras' theorem in GCSE. So what's that? That's the square root of 29. So the length of that vector there is root 29. So to generalise that, if we have a vector A and x, y, z, then to find the magnitude of that vector, we would use x squared plus y squared plus z squared, square rooted. So one of the main things you'll have to use that for is to find the distance between 2 points. So let's have a look at doing that with some. So let's go for the point A, let's say 1, 3, minus 4, and the point B, minus 5, 2, 7. So the first thing we'd need to do with these 2 points is figure out what vector gets us from one to the other. So if I wanted to find the vector that gets me from A to B, for that I'd have to use the position vector of B and subtract the position vector of A. So the position vector of B, OB, is minus 5, 2, 7. And the position vector of A is 1, 3, minus 4. So for this, I'm going to do OB take away OA. So minus 5, 2, 7, take away 1, 3, minus 4. That's minus 6, minus 1, 11. So the vector that gets me from that coordinate to that coordinate there is minus 6, minus 1, 11. So now I've got the vector that gets me from one coordinate to the other, and to find the distance between these 2 points, I just need to find the magnitude of that. So the magnitude of AB would be minus 6 squared plus minus 1 squared plus 11 squared, square rooted, which is square root of 158. So the distance between those 2 points is the square root of 158. Okay, so the next thing is just thinking of some geometry problems. So this one is from one of the exercises in the textbook. So if we've got this triangle, A, B, and C, always draw a picture with these questions. Just really helps you think about what you've got and what you need. So if the vector AB is minus I plus j, and the vector AC is, BC is I minus 3j plus k. And they want us to find the angle ABC, so this one here. All right, so that's the information that we're given. So I much prefer to use column vectors. It doesn't matter whether, if you're happy using unit vectors, then that's absolutely fine. But I just think column vectors are slightly more straightforward. So I'm going to write that the vector AB is minus 1, 1, 0. The vector BC on there is 1, minus 3, 1. And then I can see that triangle. So if I want to find that angle there, I'll call that theta. I'm going to need this vector here. Okay, so then if I have all 3 sides of this triangle, I can use the cosine rule. So To find this vector here, we can use the fact that this one follows on from this one. So the vector AC would be the vector AB added to the vector BC, which is nice. So that's -1, 1, 0, add 1, -3, 1, which is 0, -2, 1. So that vector there, going from A to C, is the vector 0, -2, 1. So now I've got all three of these vectors. For the cosine rule, I know that I need to know the lengths of the sides of the triangle, so I'm going to work that out next. So I want the magnitude of AB for the length of this side here. So that would be the square root of -1 squared plus 1 squared. So that's √2. The magnitude of BC is 1 squared plus -3 squared plus 1 squared square rooted. So that's √11. And the magnitude of AC is -2 squared plus 1 squared square rooted, and that's √5. So I've got those lengths there. So if I use a different colour, it'll make it a bit more obvious. So AB is √2, so that one is √2. BC is √11, and AC is √5. Okay. So now I can use the cosine rule. So the cosine rule is that A squared equals B squared plus C squared minus 2 BC cos A. So if I rearrange that, some people remember a different form of this. I just always rearrange it to get that. So in this is my A, I'll call that my B and that my C. They can go either way around. So cos of theta, try and get both in the screen. So cos theta equals √5 squared, which is 5, minus √2 squared, which is 2, minus √11 squared, which is 11, all divided by -2 times B, which is √2, and C, which is √11. So if I shove all of that in my calculator, which I did just before switching on the visualizer, and inverse cos both sides, so theta works out as being 31.5 degrees. So the last thing that it's useful to think about with this topic is just the applications to mechanics. So we're going to think about force, we're going to think about acceleration, we're going to think about velocity, and we're going to think about displacement and how that works between vectors and scalars. Mass and time are scalars, so we don't need to worry about those. So if we have vectors on this side and scalars on that side. So let's start off with force. So if we had a force given in a mechanics question, 1, 2, -2 newtons, then to change that to a scalar, so if it wanted the force as a scalar, we would use Pythagoras' theorem. So 1 squared plus 2 squared plus -2 squared. So that would be √9. So that would be 3 newtons as a scalar. Okay, that's the magnitude of that force. If we were to think of acceleration, it works in exactly the same way. So if acceleration was